Hello everybody, welcome to lesson 3. Today we continue with domain and range. This time we're going to work with the possibility of having an endpoint be an arrow, and you'll see how infinity ties in with these kinds of problems. So for example, you could have an arrow maybe shooting towards the left or shooting towards the right. So let's take a look at how to go about representing the domain of this graph. So like usual, since we're talking about domain, we're going to be looking at the x-axis. So you have to begin scanning the graph starting at the left. So as I start scanning it, you can see that I have my lower bound here at -6. I have an open circle, so I'm going to slice it with a dotted line here. And that's going to be my lower bound. So now I have to keep scanning and find my upper bound. Where does the graph end? So as I keep going and I keep going, you may be tempted to say, oh, my graph ends here at 3, so my upper bound is going to be +3. So let's try this. However, you'll see that as soon as I do this, you should be questioning yourself because we have an arrow here. So this arrow is actually saying that this graph keeps on extending. So now you can kind of reanalyze this and say, whoa, no, this is actually not my upper bound, right? And maybe you'll say, maybe my upper bound is 6 now. But then once you try to bound it from above with 6, you can see that you're going to be able to keep on extending this forever and ever. In other words, let's look at this point again. At this value on the graph, your x was +3. But then you extended it, and now the graph is right here. But your x value is now 6. And now let's look at this last extension that I did. Your x value is now at 8. So you can kind of see a trend going on here. As this graph keeps on extending and extending forever, these x values are going to keep getting larger and larger and larger to the point that they're going to reach or approach positive infinity because we're going in the right direction. If we were going in the left direction forever, we would be approaching negative infinity. So we can say that this graph, or we can think about it as being bounded by positive infinity. So we're actually not going to be able to bound it using a real number. So maybe you can think about maybe just having your arrow getting bounded by infinity. So representing this in interval notation, we will use the endpoints of -6 and positive infinity. And we're going to use parentheses for -6 because of the open circle, and infinity will always have a parentheses, whether it be negative or positive, because infinity is not a number. Alright, so this is our first domain with something that's not finite. So let's try another example. Let's check out this one. So now, since we are trying to get the domain, we have to again look at the x-axis. So we have to scan the graph from left to right. So I begin by scanning, right? So I begin, and then here I see that we encounter the graph, or we encounter this representation at -5. So now here I notice that we have an arrow. So since we have an arrow, we're going to use the notion of infinity. Now I'm going to cut this with a dotted line because infinity is always represented by a parentheses. So now here, just to think about it for just a little bit, and then afterwards the next problems are going to be more straightforward. But here, take a look at what's happening to the graph as it extends to the left. So let me just pick this random point right here. So this point on the graph, the x value representing that point is -3. So as I keep extending this graph to the left, and let's take a look at this point, you can see that the x value is now -4. And if I keep extending this, you can see that now my x value is -5. So the trend here is that as this graph keeps on getting extended to the left, the consequence of the x values is that these ones are getting smaller and smaller and smaller and smaller, to the point that the numbers here are going to be approaching -infinity. So then here you can see that you can think about -infinity being the lower bound. Now let's try and see if we can find an upper bound. So we're going to keep going to the right, to the right, to the right, and we find success here at +6. This is open, so I'm going to draw a dashed line here. And now it's pretty much game over. I have my endpoints, -infinity, +6. So my domain here will be -infinity, +6, and in this situation, we're going to use parentheses on both ends. This one because it's infinite, and then this one because of the open circle. And that would be the domain of this graph. So let's just take a look at one last one, which would be this one here. So if we're trying to find the domain, we have to look at the x-axis, which is already labeled for us. So let's begin scanning the graph, beginning from left and moving to the right. So we see that as we move, we encounter the graph here at -2 with a closed circle. So I'm going to cut this with a solid line, and this represents the lower bound. So now I'm going to keep moving to the right in hopes of finding an upper bound. And then here, we see that the representation of the graph ends right here at 8. However, the representation may end, but the implication is that this graph keeps on going forever. So I'm going to cut this with a dotted line. So every time you see an arrow, just cut them with dotted lines. And here, we can clearly see that the x values are going to get bigger and bigger to the point that they will be reaching +infinity. So the upper bound is going to be +infinity. So to get the domain here, we're going to use -2 in brackets because it was a closed circle, and then +infinity with the parentheses. So try these problems out, and then we'll come back and do the range.